This next module will be a continuation of the last. So we'll be talking about natural deduction and proofs. In addition to the 8 rules that we learned last time, there are 10 more that we need to discuss. Now, when we're dealing with the rules of implication, remember that underlying these rules of replacement are axioms of replacement, which asserts that within the context of a proof, logically equivalent expressions may replace each other. So when we look at certain aspects of an argument, we can see that that argument can be written in different ways, but still maintain the same exact meaning. So, for example, earlier in this course, we looked at or saw De Morgan's law or De Morgan's rule. This is a rule of replacement that we use when trying to write or understand arguments. I may see an argument written one way, but then I can write it or say it another way without losing meaning. So, for instance, when I do this within the realm of symbolic logic, I use a double colon to signify what's on the left is equivalent to what is on the right. Now, these 10 rules, in addition to the 8 rules of inference that we looked at last time, can help us naturally deduce conclusions and make us more confident in those conclusions based on how it is that we're getting from one step to the next with our thinking and natural deduction. Again, we do this kind of thing without even thinking about it. But by learning these rules, we are able to justify why it is that we think that certain things can be deduced from other things and how we get to certain answers. That way, if there's any question as to how I got from step 1 to step 2 to step 3, I can express that justification through a rule of modus ponens, or perhaps a rule of replacement such as De Morgan's, which we'll look at more in this series. The first 5 rules of replacement are De Morgan's rule, commutativity, associativity, distribution, and double negation. Looking back at De Morgan's rule, which we looked at earlier in the class, notes that if I were to make the claim that it's not the case that P and Q is true, what I'm saying is that not P or not Q is true. And vice versa. If I tell you that not P or not Q is true, then it must be also true that not P and Q is true. Similarly, if I say not P or Q is true, then it must also be the case that not P is true and not Q is true. These 2 ways of writing these complex propositions are interchangeable. So that if we were to write it in either of these ways, we can feel justified and confident in knowing that they are equivalent statements. Now, this might help us because when we couple these rules of replacement with the rules of inference that we learned last time, we're able to naturally deduce and justify certain conclusions and how we get to certain conclusions based on the complicated nature of propositions and arguments. The next rule is the commutativity rule, in which case, if I say that P or Q is true, then it must be the case that Q or P is true. I'm able to reverse these, and not necessarily, it doesn't necessarily matter which comes first or second. Same with conjunctions. So disjunctive and conjunctive claims both work according to commutativity, in that if P and Q is true, then Q and P is true. And just think about that in terms of what P and Q or P and Q might mean. If I tell you that I'm going out surfing or I'm going to sit at home and record a lecture, then it must be the case that I'm going to sit at home and record a lecture or go out surfing. Similarly, if I say I'm going to go out surfing and record a lecture today, then it must be the case that I'm going to record a lecture and go out surfing today. So it doesn't matter which order we say these in, we can replace one with the other because they are logically equivalent statements. Associativity is the next rule of replacement. So that if I say P or Q or R, then what I'm essentially saying is P or Q or R. So here, it doesn't matter if we have a purely disjunctive proposition, or if I have a purely conjunctive proposition in the bottom, P and Q and R, or P and Q and R. It doesn't matter necessarily where we put the parentheses. The parentheses will only really matter when we're using differing symbols within the same complicated, complex proposition. But if we're just using all disjunctions or all conjunctions, and there's only 3 simple elements, then it doesn't matter where we put the parentheses, and we can essentially, if need to, move parentheses over if we need to break down the complex proposition into more simple propositions, perhaps for the rule of simplification in order to justify some sort of conclusion. Now, distribution is another rule that we use, and this rule says that P and Q or R is equivalent to P and Q or P and R. Notice how in the top left we see that P is on the outside of the parentheses but inside the brackets, so it's P and one of the 2 elements, Q or R. So we can essentially say, well, it's either got to be P and Q or P and R. So we can see that written in the top right. So these are equivalent statements. Similarly, the argument or the complex propositions at the bottom, P or Q and R is logically equivalent to P or Q and P or R, using the same essential rule or method. Again, we're doing this so that we can write arguments in different ways, so that we can extrapolate out or incorporate in different information that may be naturally deduced to get to a conclusion. And so we can follow these rules to guarantee ourselves that justification to get us from one step to the next. Double negation is also an instance of replacement. If I were to make the claim that P, then it would certainly be the case that not P is also true. So a double negation, just like in math, cancels the negations to where you get what you started out with. Now, when it comes to these first 5 rules, some common strategies might be that conjunctions can be used to set up De Morgan's rule. Similarly, constructive dilemmas can be used to set up De Morgan's rule. Addition can also be used to set up De Morgan's rule. And note that distribution can be used in 2 ways to set up a disjunctive syllogism. So all you need to do is go back and look at De Morgan's rule or this disjunctive syllogism to see how it is that these constructive dilemmas, additions, and conjunctions all apply to the same rule. Again, these are all ways of manipulating and altering the way in which we say complex propositions that mean the same thing, but that we can naturally deduce one thing from another that we may not necessarily be able to do if we didn't apply De Morgan's rule in the first place, or didn't apply the disjunctive syllogism in the first place. Also, distribution can be used in two ways to set up simplification, and note that inspection of the premises does not reveal how the conclusion should be derived. Consider using the rules of replacement to deconstruct the conclusion, which again essentially means that we might need to replace one propositional form with another in order to derive certain conclusions. Now, the next 5 rules that we're going to look at are transposition, material implication, material equivalence, and exportation and tautology. Transposition is essentially that if I were to say if P then Q, it would logically mean the same as if not Q, then not P. And we can see how this may work by referencing back the modus tollens rule. But again, these two propositional forms are equivalent. Just like with material implication, these two material forms are equivalent, that if P then Q, not Q, then P. Next is the material equivalence. P if and only if Q means if P then Q and if Q then P. Remember, we can see the double-sided arrow means that both P and Q are necessary and sufficient for one another. So it can be written in both ways. Typically, with a conditional statement, it needs to be written in that one way because one is sufficient for one and one is necessary for the other. But using a biconditional, such as if P if and only if Q, we see that both are necessary and sufficient for one another. Similarly, if I say P if and only if Q, I can say P and Q, or not Q and not P. So again, if we were to somehow see something written in the form that's in the right column, we can simplify that over to what's written in the first column. Or similarly, if we need to extrapolate something from P if and only if Q, we can do so in a number of different ways using these longer, complicated propositional forms. Next, with exportation, if P and Q then R, we can logically say the equivalent is that if P, then if Q, then R. So again, different forms, different ways of writing it, but logically equivalent. Important because we can deduce certain information when said differently and justify why a conclusion might be the conclusion that it is. Last is the tautology, so that if I say P, it's equivalent P or Q. If I say P, then it's equivalent P and P. So here, very similar to addition, very similar to simplification, and so with this form, we can simply just kind of add on other pieces, or just state naturally that something is the same as what it is. Now, With these rules, we can look to the idea that material implication can be used to set up a hypothetical syllogism. We can see that exportation can be used to set up modus ponens and modus tollens, and addition can be used to set up material implication. So I would recommend going back and comparing how, for instance, exportation and modus ponens go together, or how material implication and a hypothetical syllogism can go together. So when we start to memorize these different rules, we can see how they feed off of each other in order for us to naturally deduce information. Other things to think about are the ideas of transposition. Can be used to set up a hypothetical syllogism and constructive dilemma, and how a constructive dilemma and material implication can be used to set up tautologies. Lastly, material implications can be used to set up distribution. So again, go back and view these side by side and see how they relate, so that when we create a proof, which is what you saw in the prior module, the beginning of the prior module, we can go down through a standard form argument and justify how it is that we can deduce one thing from another in order to get us to a conclusion, and therefore justify and guarantee a valid argument form.